Welcome guys to my YouTube channel. In today's class, I'm going to be teaching you 10 JAMB questions on radioactivity, okay? Also called nuclear chemistry. So we are going to begin with the first question. The first question says, which of the following cannot be deflected by a magnetic field? Don't forget, in radioactive reactions or radiations, there are three major types of radiation. We have the alpha, the beta, and the what? Gamma. If you have not watched my videos on radioactivity part 1, part 2, and part 3, please do well to watch that video, okay? Now, the answer to this question is, okay, so which of the following cannot be deflected by a magnetic field? Don't forget that there are three major radiations. We have the alpha, which is positive. We have beta, which is negative. We have gamma, which is what? Neutral. So take note of that. So when they are requesting for the radiation that cannot be deflected, it must be neutral. So which one of them is neutral? Is it alpha? No. Is it beta? No. The answer is what? Gamma. So it's not A, it is not B. The answer is what? C. So it should be noted that gamma ray cannot be deflected by an electric field, neither by what? A magnetic field. Note it down. Write it down. Alpha can be deflected. Beta can be deflected. Do you understand? We can deflect both, but we cannot deflect what? Gamma, because it is neutral. Now, question number 2. Which of the following is a best absorber of X-ray? Don't forget, now, the best absorber of any ray, whether radioactive or electromagnetic, the best absorber is lead. And that is why even the walls of nuclear plants are built with lead, concrete, and what? Iron. So it should be noted that the answer is not hydrogen, oxygen, calcium. The answer is what? Lead. Lead is the best absorber of radiations. Yes, lead is the best absorber of radiations. Question number 3. What is the number of neutrons in uranium isotope? Now, don't forget that if I have an atom like this, the number on top is the mass number. The number below is the atomic number, which is also called the number of what? Proton. So if I write 238.92 uranium, something like this, this one here is the mass number. And this mass number is proton plus neutron. Please note it. This one now is atomic number. This atomic number is proton alone. Wow. So it means that if I'm looking for the numbers of neutron, I will simply say the mass number, which is the two of them, minus the only proton, so that it becomes 238 minus 92. That will give us 146. Let's confirm it. 238, 92, 6 here. Borrow one, you put it, you have 4. So you have, 146. So note it that numbers of neutron is the mass number minus the atomic number, which is the proton number. So the answer to this question is 146, option B. Question number 4. Which of the following is most strongly deflected by a magnetic field? Now, I've told you that gamma cannot be deflected because why? The guy is neutral. It does not have charge, so it cannot be deflected. But your alpha and beta can be deflected. Now, in that case, they're asking you which one among these two is mostly or strongly deflected. You will have to consider something. Watch this, please. Watch this carefully. Alpha, which is deflected, is like this. Should be the get. So alpha has a mass number of 4, an atomic number of what? 2. Beta, which is also deflected, is like this. An atomic number of -1, a mass number of what? 0. So let me ask you a simple question. Between alpha and beta, which one do you think is highly massive? Which one is heavier? Of course, from the look of their symbols, you will discover that beta is the what? Lightest among them. Lightest particles. Yeah, it's the lightest particle here. It's lighter than this guy. Even when you compare alpha, beta, and gamma, beta is lightest. It's the lightest among them. So for that reason, it will be more strongly deflected. Take note of that because it's very light. Do you understand? Gamma ray is not deflected at all for two reasons. One is neutral. Two is highly massive. The weight is heavy, so it cannot be deflected by electric or magnetic field. So that means the lighter the particle, the greater the what? Rate of deflection. Is that understood? Okay, so the answer is not gamma, is not alpha. The answer is what? Beta. Of course, you know that this one is out of the point. So X-ray is electromagnetic wave, it's not radioactive. Now, in the series, take a look at this series class, look this series carefully. In this series, you have a substance that has a mass number of 235, an atomic number of what? 92 is L. All of a sudden, that substance turns into another substance where the mass number is 235 and atomic number is 93. What do you think must have happened to this substance? The mass number remains the same, but the atomic number has increased. Listen, if you look at beta, you see that it has -1. The mass number will always remain the same because it has a zero mass number. So beta now is -1. Because it's -1, if it leaves a substance, the substance will increase by 1. Why? Because it's -1. As it's leaving, the substance will increase by 1. So you must know that at this point, what we have here is beta particle. Beta has been what? Emitted. Because watch, if I add the beta here now, for instance, I add it here. 93 minus 1 will return back to 92. So whenever a substance emits beta, I've done that in my previous video. Okay, now watch this carefully. From here, this same guy transformed to become what? 23593. Wow, with the symbol N. Abba, what has this substance emitted from this place? Class, the mass number remains the same. The atomic number remains the same. The particle must have emitted gamma. So note it, it has emitted gamma. Again, it now transformed into another substance, which is 23191 of P. Abba, listen to me, class. Listen. Beta means that the atomic number will increase by 1. That's why it turned from 92 to become 93. You get now? Now, this guy now remains the same. Yes, yeah, it remains the same. If you emit gamma, the mass number and the atomic number remains the same. That's why we say it's gamma. Finally, here, what has it emitted from here? From 234, 5 to 231, it has lost 4 mass number. From 93 to 91, it has lost 2 atomic numbers. So we have a particle with a mass number of 4 and an atomic number of 2. That particle must be helium, and that is alpha. So the particle that it has emitted respectively is beta, gamma, and what? Alpha. This is the answer to the word question. Don't forget, we have more questions for today. We are looking at 20 likely JAMB questions on radioactivity. Stay connected. Now let's take this question. Question number 6. Isotope and nuclei which have what? What do isotope have? First of all, what is the meaning of the word isotopes? Isotopes. What does this word mean? Understand that isotopes are atoms of the same element that have the same atomic number but different mass number. Yes, due to the difference in the numbers of neutrons. Please note that. Isotopes have atoms with the same atomic number but different mass number. I'll give you just one illustration because of time. So you have 3517 of chlorine and 3717 of chlorine. Take a look at this guy. The atomic number is the same, but the mass number is not the same. Why? Because the numbers of neutrons for both atoms are not the same. How? What do I mean? Neutron here now 35 minus 17. The first one, the neutron, will give us 35 minus 17 will give us 18. The second one, the neutron will give us 37 minus 17 will give us 18, 20. So understand, say, isotope now atom of the same element possessing the same atomic number. Atomic number and a number of proton. So number of proton will be the same here. But the number of neutrons will not be the same. So let's look at the option. The same number of electrons and protons. Wrong. The same atomic number but different numbers of neutrons. Correct. The same atomic number but the numbers of neutrons are not the same. The mass number are not the same. Okay, take note of that. That's the answer. Number 7, one of the property of gamma ray is that they are dash. Watch my previous video, you get this word. Now, one of the property of gamma ray is that gamma ray is neutral, 2 is highly massive, but little is known of the mass. So when you consider the option of negatively charged, we know that that one is out of the box. We have massive, we have neutral, we have positively charged. Positive charge is out of the box. So we are left with massive and neutral. Now, gamma ray are known to be what? Neutral. So lithium is known of this. So we choose C as our word, as our answer. Please look at number 8. Which of the radiations does not originate from the nucleus? Understand? Radioactive radiation are radiation emitted from the nucleus. They are gotten from the nucleus of a radioactive substance, and these radiations are major and minor. The major is alpha, beta, and gamma. The minor is neutron, proton, and positron. Yes. So understand this, okay? So they are from the nucleus. Let's look at the options. Alpha is from the nucleus. Beta is from the nucleus. Gamma is from the nucleus. But the answer will be what? D. Which of the radiations does not originate from the nucleus? X-ray is not from the nucleus. X-ray is produced by allowing fast-moving electrons to bombard heavy metals such as molybdenum and tungsten. So take note that X-ray is not radioactive, neither is it gotten from the nucleus of an atom. So it's at. The answer is what? D. Question number 9. If a radioactive substance has an half-life of 2 minutes, calculate the decay constant. Please calculate decay constant for me in seconds. Yes, the option in this question was given in seconds, even though I didn't copy the option, but it was in seconds. So what do we do first of all? The first thing we have to do is to convert the what? The half-life from minutes to seconds. The half-life is denoted with the formula. This is the symbol, 2 minutes. 2 minutes converted to seconds, we multiply by 60, so it's 120 seconds. Now take note of this. This time is 120 seconds. Remember that our half-life has a formula which is 0.693 over what? Decay constant. So our decay constant will be 0.693 over your what? Your half-life. So that will give us 0.693 over half-life, which is what? 120. Let's do that quickly with a calculator. You have 0.693 divided by 120. We have 5.8. 5.8 times 10 raised to power minus 3. 10 raised to power minus 3 per second. That is the words, the decay constant. Now, question 10. Cancerous cells can be destroyed by words. What is the ray used for destroying cancerous cells? Class, we've known before now that gamma ray is used for destroying cancerous cells, but gamma ray now is not in the option. Now what do we have to do? We have X-ray. There are 2 types of X-ray. We have the soft X-ray and the hard X-ray. The hard X-ray can also be used to destroy cancerous cells. That's why the answer to this question is what? C. Now we have come to the end of today's class. We are going to take the 10 other questions in our previous class. Please subscribe to this channel, on your notification bell, like our video, share it to your friends, and also tell us what you feel about the questions that we have answered in the comment section. Thank you very much. I'll see you in my next video lesson.